902, providing a place where you can learn and enjoy math and chess.
See, the ophthalmologists are studying a beehive to determine how the outdoor temperature affects the activity of the bees. The scatter plot shows the number of bees leaving the hive per minute at different temperatures. Each point on the graph represents the number of bees leaving the hive per minute at a particular temperature. What does the slope mean? So, remember, slope is the change in y over the change of x. So if I pick the y variables, that's the bees leaving per minute, and then the x is temperature. And it's easiest when working with slope is for every increase in one temperature, so the change in x, you might have, I don't know, so for every little one, how much are you increasing? That might be a little bit difficult to get a number based off that case, but let's just go through each of these scenarios for question number 3. The slope represents the change in temperature when the number of bees leaving the hive. So this would be x over the y. And per means the division. So it's not that one. The slope represents the change in the number of bees leaving per minute. So that's the y. Per no, that's the wrong per. When the temperature increases by 1 degree. So the 1 degree is good because that represents R1. So that would be good. The slope represents the change in temperature. So again, that's the x. When the number of bees leaving the hive per minute decreases by 1. So they're saying x divided by 1y, which would be wrong. D, the slope represents the change in number of bees per minute leaving. So that would be a y. When the temperature of decreases by 1 degree, so that would be a negative 1x. So that would be wrong. Therefore, our answer is going to be B. B for bees! Sorry. Scatter plot shows the age and sale price of 15 used motorcycles. Describe the association in the scatter plot. Yours was a drop down, but I'll just be writing stuff here. The scatter plot shows well, if I look at this line here, that would be a negative. And then association between the age of the motorcycles and the sale price. So I notice as I go towards the right, so as the age increases for the motorcycle, the sales price is decreasing, meaning the numbers are going down as I go towards the right. This is a decreasing. The motorcycle, because of the age of the motorcycle increases, the sale price of the motorcycle, the price of the motorcycle decreases. 1 point each. The ages of parents do not show causation. Do not, I'm going to circle that one, because association is never causation. We can say that there's a strong relationship. We can say it's positive or negative, right? We can use our SHS. It says choose the best answer there. So 10B, the answer is A. Question number 11. Miss Brubaker is a guidance counselor at Apple Grove High School. She is giving a presentation to the freshman class about the importance of studying and getting good grades. In her talk, she likes to show the freshman data she has collected about some students who went to the high school and their progress in college. The data for the 12 students and their GPAs, as well as their first year college GPA, the table shows the data she has collected. Okay, what is the explanatory variable? The explanatory variable explains, helps explain the response. Explains this. Well, here, not because it's showing to us, but the high school GPA explains your college GPA. So, age A is going to be high school GPA. And what is the response? That would be college GPA. Okay, construct a scatter plot using data on your own graph paper. I mean, you can just put that in and get it to your calculator. Let me do that. Let's see if this thing doesn't crash on me. If it crashes on me, I might not throw away. I'm tempted to throw this thing. 2.22. Just putting in all the numbers. It's Christmas and my calculator on my tablet's not working. The very next day, you did it again. This Christmas. You knew it's something done special. 288. Okay, let's go to list 2. And this is your college GPAs. 2.35. 2.8. 388. 3.4. 2.95. 310. 355. 392. 340. 350. 352. And 2.90. Okay, I'm just going to go press second y equals to get a graph. Click that. L1, L2, yes, and then press graph. Okay, ignore that green one because I didn't actually create an equation. If you wanted to, we could do that. Stat, calc, linreg, list 1, comma, list 2, comma, 1, comma, vars, y vars. Okay. And then when you press graph, it should be there. Boom. Oh yeah. Okay, there's my graph. So what do you guys think? Describe it, SHS. Shape, linear. Unusuals, no. Direction, positive. Strength, strong. That's what I would describe it with. So, is there association? Yeah, I think it's C. I think it is linear. And you can, another way of double checking that is our correlation was strong, and the coefficient of determination was also very strong, 0.86. So yes. Okay. D, is there a positive or negative association? So I'm going to say positive. Which order pair for the student with the highest, write the order pair for the student with the highest GPA. High school GPA. So I'm looking at this list here, and 342, 3438. So I see 3.80, comma 3.92. That's the order pair. Okay. E, the x coordinates are the high school, and then the y coordinates are the college GPA. So D, blah, 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 blah. That one's worth 7 points. Okay, number 12, I think the last one. A linear model shows that relationship between the grocery item numbers, number of grocery items, I don't know, 0 to 20, purchase, and the total cost, money, $0, $100, has a correlation coefficient of 0.97. So got to be strong, right? Okay. Which statement about the variables is true? Purchasing more items causes a higher cost of grocery bill. Okay, this is the red flag problem. No. Although there is a strong correlation or association, the association is not causation. This does not cause that. Okay, we can present a strong relationship, right, with the correlation coefficient and all those things, but that's the red flag word. Don't use that one. Okay, all right. A grocery bill has a higher cost than, so high, then the more items must have been purchased. That's a strong statement saying if then it must be this. And I would say that this one is false, because you might go to the grocery store like I did around Thanksgiving and you want to buy steaks and they were like crazy high. So just because you buy a lot of items doesn't, or you buy lobster, that's not the case. Okay, C, there is no relationship between the number of items purchased and the cost. No, we know that because we have R equals 0.97. And D, there is a strong relationship, I like the word strong, between the number of items purchased and the total cost of a grocery bill. Yeah, that's it. All right, let's go over this question number 7. A doctor randomly selected patients from different age groups. He compared relationships between X, the age of years, and Y, the height in inches for each patient. The scatter plot below shows the doctor's data. OB is a 5-year-old patient. So here's 5, who has a height of 39 inches. So 39 inches looks like right there. So there is OB. Based on the line of best fit for the scatter plot, what is the approximate difference of OB's height and the expected height? So when I think of this, I think of the actual minus the predicted. And basically that's a vocab word called the residuals. So his actual height is 39. I got that from here. And then the predicted for a 5-year-old, let's try to get a different color here. If you go all the way up on the line, I think that's like maybe 41, 42. So you'll notice that the red dot is below the line of best fit. Below the line of fit. That's why it's a -3. So OB is a little bit shorter than what he should be, and that's called a residual -3, -3. Okay, question number 7. I don't even know what that is. An ornithologist wants to look at the relationship between the breadth of a peregrine falcon egg and the mass of the falcon chicks that hatch from them. The data show a linear pattern with a summary statistics below. Linear pattern, so that is an least squares regression line, and then summary statistics. So this is the one where you have two formulas, because I allow you to, and I'm just going to pull out my formula sheet. And so I'm going to copy down what I have from my formula sheet. So I have y hat equals a plus bx. Okay. Now, if you chose to use b plus ax, it doesn't really matter. It's just you need to know that this one has no x. So this one is my y-intercept. And for the y-intercept, the formula is a minus equals y bar minus b times x bar. Now, if you notice that this formula has a b value, so we're going to have to calculate the b first. So the one in front of x, this is called our slope, and the slope formula with summary statistics is b equals r times sy over sx, the standard deviation. Okay, let's go ahead and find these. So my correlation is here. The standard deviation of y is here. And the last one, we will use red. Sx is here. Let's put those in. B equals 0.95. This is a fraction, so 4.6. And red is 2.3. And I'm just going to make this a longer fraction. I'm going to multiply the top and the bottom, so let's go ahead and do that. Let me show you, so I'm going to take a picture of my work. I'm at the home screen, so I'm going to press 0.95 times 4.6 divided by 2.3. And we have an answer of 1.9. Okay, so this value here, B, is going to go right there. And then let's get some other ones. Our average for the y's is going to go here, and our x bar of 41 is going to go there. Okay, let's fill that in. So y bar is 33.6 minus a b value, which we just found, which is 1.9 in purple there, and an x bar that is 41. Okay, remember I'm going to do PEMDAS here, so I'm going to multiply those two numbers. Okay, let me take a picture so you can actually see the calculations I'm putting into my calculator. I think it's super helpful. So I have 33.6. I always like to use extra parentheses. In this case, you can use the subtraction or minus sign. 1.9 times 41. And that gives you negative 44.3. Negative 44. Negative 44.3. Okay. So to put that all back together, I have y bar equals my a value, which is negative 44.3, and then my b value, which is a positive 1.9x. Or you can also have, if you just change it around, you can have 1.9x minus 44.3. Okay, so let me just highlight that. Any of those values could be your answer. Okay, now it told me to round my entries to the nearest 10th, but either's would work. Question number 9. In a lab, I don't have question number 9. Okay. In a lab, a biologist watches how fast a virus, maybe like the coronavirus, replicates. He records the following data. Use a exponential regression equation to determine the number of viruses after 1 day. All right, let's put this in. Wherever you are, stat, edit, list 1, clear, enter, list 2, clear, enter, 0, 2, 5, 9, 16. 197, 225, 290. Remember, they're kind of telling us use the exponential, but if you use the residuals, the residual plot, and coefficient of determination would help us to figure out if it's linear, quadratic, exponential. Okay, now I'm going to press stat, calc, and then I'm looking for quadratic regression, which is exponential regression, which is A. Then we're going to do our second 1, second 2, comma 1, comma, vars, y1. And of course it crashed on us. Did not like us. Let's try that again. Stat, calc, and then I'm assuming it's still in that list. Vars, y1. Yes! Alright. Okay, there's my equation. And let me just pop over to, some reason it didn't show up. 9, question number 9. Okay, it says use the exponential regression equation to determine the number of viruses after 1 day. Okay. So let's think about this. You might have been thinking like me, I don't know, 1 day. You might have been thinking 1 here. But what does the X here represent? This represents hours, time in hours. So how many hours in 1 day? You're actually representing 24. Because is one of my answers, this is how I was thinking about it, is one of the multiple, if you thought it was 1, is one of the multiple choice answers between 197 and 225. That's not the case. So we're going to have to put in 24 here. Let's go to table, type in 24, and I will get, that's bad. Let's see. That is my linear regression. And got 24.888. Based on our, I would expect this to be greater than 695. All right, let's make sure all my numbers are correct in my exponential regression. Stat, edit. Let's try that again. Maybe I didn't input it. I don't remember. 0, 2, 5, 9, 16. Enter. And then 197, 225, 290, 400, and 695. Stat calc exponential regression L1, comma L2, comma 1, comma vars, y vars. Crashed again. Oh, please. And of course, alright guys, I'm just doing this by hand. Well, if you did get the number, the answer is A, 1235. Mine keeps crashing for now, so I'm just going to quickly put this into my calculator that you can't see. 0, 2, 5, 9, 16. Clear. 197, 225, 290, 400, 695. Stat calc exponential reg. Vars, y vars, function y1. Calculate. Okay. Let's just use what I got here. Okay. So I have y equals abx, so 194.806. My b value is 1.083 to the x power. X equals 24, so we're going to put in there to the 24th power. And if I do that, my prediction is going to be 1313.5. Okay, this number is using the table value. So I'm going to try, of course it's not close to that number, it's close to that number. So let's go ahead and put this into my calculator. Take a picture, I can actually do this. Don't quit on me now. All right, 1.94. Delete. 194.806. 1.083. Okay, caret 24. Okay, I got 1320. So the closest one there. So this was using the calculator, and then this one yielded 1320. So this is the closest one here, and the answer is A. Okay.
Want to go from hating to loving math? Subscribe to David Ng's channel to learn new ways to do math.